Did you know that DNA can let us look into the past? It allows us to see the history of a species so we can think about the future. And this is very important today when humans are modifying the climate a lot, which is causing many changes in the environment and forcing species to move around to try and cope with changing landscape. However, not all species will be equally affected by climate change. Species are different in their ecology, which will make some species be more affected than others. So how can we predict that? This is what I'm trying to investigate in my PhD in the Carnival Lab at City College of New York. I'm trying to understand what makes a species respond differently to the same environmental change. And this is simpler than it sounds. I first choose an area, which is this one, the Atlantic forest of Brazil, an area with high species diversity and very threatened today by human activities. And then I pick a few species. I love birds, so I'm choosing a bunch of bird species with different ecologies. From a few that are very small and very dependent on forests like this one, to others that are bigger like this one. And also species that occupy different areas in the forest, like this one that mostly looks for food up high in the canopy, and these ones that rarely ever leaves the ground of the forest. These little ecological differences are what makes the species so different in how they are affected by climate change. Look how bigger species can disperse more than smaller species, or how species that are way high on trees can disperse much better than those on lower levels. If they disperse better, it means they can move around more quickly, looking for a better environment when their habitat is affected by climate change. For instance, in past climatic change, when the globe was colder and more humid, forest fragments increased in some places, and some species spread out very fast, whereas the smaller species took some more time to track the new suitable habitat. In other situations, when the climate was hotter and drier, forest fragments became smaller in some places, but big species that used to be in the canopy may have not been affected at all, because they were able to move through the non-forest areas easier than smaller species that are very dependent of forests. All these differences will have effects on the DNA of the population. Species that are less affected by climate change will exchange DNA easier among fragments, whereas species that are more affected will not exchange DNA so easily. In the first case, each fragment will tend to have higher genetic diversity, whereas in the second case, the fragments will tend to have lower genetic diversity. And this lower genetic diversity is bad. It means the species will have less chance to adapt to new environments. So, by looking at the DNA of a species now, we can see what happened in the past and then compare their DNA to see their different responses and correlate that to their ecology. In this way, by sequencing DNA, we can look into the past and understand how ecology affects the way that a species responds to climate change. Then, we can try and predict how the species today will respond to what we have been causing in the planet, and create plans to try and protect them, keeping in mind their ecological differences. Thanks for watching, and if this topic got you interested and made you have some questions, feel free to hit me up on email or Twitter. Happy Humble Day!